For this lecture, you need to understand some of the previous concepts around networking and also around creating containers. Now that we understand the concepts of Docker networking and how all the virtual networking and IP stuff works, let's look at some of the command line options for managing it. So first, there's the obvious network ls. Since we can create multiple networks, we surely have an ls command to list them. We have the usual inspect command, which you're probably used to by now from all the other inspecting we're doing, and that'll show us the details about a specific network. And then we have a create command that has an optional driver that we can specify for using built-in and third-party drivers to create a new virtual network. And then we have the connect and disconnect commands for changing a live running container so that a new NIC is created on a virtual network for that container. It's kind of like sticking a network card in a computer while it's running. So here we go. Okay, so back to my command line. And taking the concepts that we just learned, I can actually do a docker network ls. And this shows me all of the networks that have been created. Now in this case, when you run the same command, you're probably going to see the same three. And depending on your operating system and version of Docker, you might see the bridge network called Docker 0 or bridge, but they both mean the same thing, which is it's the default network that bridges through the NAT firewall to the physical network that your host is connected to. And up until now, we haven't had to worry about it because all of our containers have just attached to that network and worked. But now that we have this Nginx container running, if I do a docker network inspect the bridge network, you'll actually see that it lists the containers attached to that network. And you'll see that our Nginx one that we called web host is attached there. You can actually see its IP address. And you'll see up here that these networks automatically assign IP addresses, and it's showing you here with the IPAM config that the subnet defaults to 172.17, which is typically the default network for any Docker host, but it can be changed. And then the gateway for this network that will eventually route out to the physical network. And if we went back to the Docker network ls, we can see these other two networks. The host network is what we talked about before, that is a special network that skips the virtual networking of Docker and attaches the container directly to the host interface. And as you can imagine, there's pros and cons to that because it prevents the security boundaries of the containerization from protecting the interface of that container, but it also, in certain situations, can improve the performance of high throughput networking and get around a few other issues with specific special software out there. And then we have the last one of none, which is kind of the equivalent of having an interface on your computer that's not attached to anything, but we can create our own. So let's create a Docker network create my _app_net. All right, now we're going to do a Docker network ls again. And you'll notice that it created my new virtual network with a driver of bridge. And that's because that's the default driver. It's a simple driver that simply creates a virtual network locally with its own subnet somewhere around the 172.17 and above, because it'll increment as it goes, so 17, then 18, 19, 20, and so on. And it doesn't have any of the advanced features that we might see later in this course, like overlaid networks that allow private networking between hosts, and other third-party drivers like Weave. And if you look at the Docker network create command with help, you'll see that I can specify not just the driver that I want to use, but a lot of the IP and network options that you might need in an advanced scenario. Now, we can do several things with these networks and how we connect them to our containers. We can use the -- network option when we create a container. So Docker container run name new Nginx, and then network, and then my app net, and then the Nginx image. And if we did a Docker network inspect on the my app network, you would see that the new Nginx I just created is now on that network, and it has a new IP address of 172.1.8, so it's the next subnet in the list. But we don't actually have to start new containers, because just like in the real world where you can unplug and replug in Ethernet devices and reconnect to wireless networks, you can also do the same with existing networks and existing containers. And for this, we use the Docker network connect and disconnect options, and you can use -- help to see all the options there for Docker network. And in this case, what we want to do is Docker network, and we want to take the existing container that we created first and connect it to our new network. So I'm going to pick the new MyApp network, and then I'm going to pick the original web host we created. And now if I do a Docker container inspect of my original web host, you'll see that it's actually now on two networks. The original bridge network, and I basically did the equivalent of giving it a new Ethernet interface on a different network with a different IP that was received from the DHCP. So we're now on the 17 network and the 18 network. And if I wanted to disconnect that, I could do the same with just disconnect. And then if I went back and did an inspection again, you'll see that it's now back with only the one network. So as you can see, there's lots of interesting options for Docker networking, and really the end goal here, and one thing I love to brag about with containers, is that if you're running all of the applications on a single server in this case, you're able to really protect them. Because in the physical world where we were creating virtual machines and hosts in a network, we would often overexpose the ports and networking on our application servers. So in these cases, if you were to take your app containers and have them all in one network together in a virtual network, you're only going to be exposing the ports on your host that you specifically use the -p with, and everything else is a little bit safer with that protected firewall inside their virtual network. Now later on, when we get into Docker Swarm, we're actually going to learn about multi-host networking and how this gets even better when we start to scale up and scale out. So to recap, we just covered a bunch of commands for managing Docker networks. We played around with the ls and the inspect commands, created a Docker network, and used the default driver of bridge, so we didn't actually need to use the -- driver. And last, we tried out the network connect and the network disconnect commands for adding and then removing a NIC from a running container.